We're going to take a look at the practice problems on page 112 of your book, and these are number 17 and 18. Number 17 is asking how many neutrons are in each atom, and we're looking at the shorthand version here for each element. So this is the shorthand version for oxygen 16, okay, and the subscript here tells us the atomic number. The superscript here tells us the mass number. So what we need to remember about this atomic shorthand is that the atomic number here is equal to the number of protons in the atom. And the mass number is equal to the number of protons plus the number of neutrons. So how would you find out the number of neutrons? In order to get the number of neutrons, you would take the mass number minus the atomic number. You take this number minus this number. Since you're taking number of protons plus neutrons minus the number of protons, you're going to end up with the number of neutrons. So the number of neutrons equals the mass number minus the atomic number. So we can go back now and look at our problems, and we turn here to oxygen 8. Okay, this is oxygen 16 really, and this what we're referring to here with oxygen 16 is it's oxygen with a mass number of 16. How many neutrons would it have? Well, 16 minus 8 is 8, so it has 8 neutrons. Our next example, letter B, is sulfur 32, and its atomic number is 16. So 32 minus 16 is 16. It has 16 neutrons. In letter C, silver has a mass number of 108. Its atomic number is 47. So 108 minus 47 is 61. Silver has 61 neutrons. In letter D, bromine has a mass number of 60, an atomic number of 35. 60 minus 35 is 25 neutrons. In letter E, lead, 207, which is its mass number, has an atomic number of 82. So 207 minus 82 is 125. So lead 207 has 125 neutrons. So calculating the number of neutrons is really easy when you have the elements in this shorthand form, and I'm putting the shorthand form here in boxes. Remember that the superscript is the mass number and the subscript is the atomic number, okay? That number of neutrons that we calculated below is not part of that atomic shorthand. We just have to calculate it separately using that equation here. In number 18, we have start out with carbon 12, the element carbon 12. This is carbon with a mass number of 12 in letter A. How would we express that in atomic shorthand? We'll use the letter C for carbon. Its mass number is 12. When we look at the periodic table, its atomic number is 6. So there's our atomic shorthand for carbon 12. In letter B, fluorine 19 is what we're looking at. The chemical symbol for fluorine is F. Its mass number is 19. Its atomic number from the periodic table is 9. So there's our chemical shorthand for fluorine 19. And in letter C, beryllium 9. The chemical symbol for beryllium is Be. Its mass number is 9. Its atomic number is 4. So all of these are the atomic shorthand for those elements. Continuing with isotopes, on page 113 of our text, number 19, we went to write the symbol for the following isotopes: oxygen 16, oxygen 17, and oxygen 18. So we're using atomic shorthand here. So we're referring to the mass number here, so the mass number becomes the superscript. And when we look at oxygen on the periodic table, its atomic number is 8. Remember, the atomic number gives the element its identity. So this is the shorthand for oxygen 16, excuse me. The shorthand for oxygen 17 would have the mass number of 17 here and the atomic number of 8 here. The shorthand for oxygen 18 has the mass number of 18 here, the atomic number of 8 here. In number 20, we have chromium 50, chromium 52, and chromium 53. Again, we want to write the atomic shorthand for these. So the symbol for chromium is Cr. The mass number is here, so the mass number is 50. That becomes the superscript. On the periodic table, the atomic number for chromium is always 24. So there's our atomic shorthand for chromium 50. How many neutrons does chromium 50 have? Well, we take the mass number minus the atomic number. So 50 minus 24 is 26 neutrons. For chromium 52, the atomic shorthand would look like this. How many neutrons does chromium 52 have? Well, 52 minus 24 is 28 neutrons. And lastly, chromium 53 has the atomic shorthand of this. And so see, in each one here, the atomic number has not changed. It's always 24. It can't change. That's what gives the element its identity. Chromium always will have 24 protons in its nucleus. However, its mass number can change because the number of neutrons can change. So in chromium 53, it has 53 minus 24, which is 29 neutrons.